In Lesson 1.5, we're going to look at if-then statements. Our learning target today is I know the parts of a conditional statement. We also want to find the truth value of a statement. Our essential question is, how do if-then statements describe mathematical relationships? Our vocabulary. The words that we start with today are different than what we've seen. Our vocabulary words are conditional statement. So a conditional statement can be written in the form of if P, then Q. The notation or symbols that we use can be written as P first with an arrow and then Q. This is read if P, then Q. The hypothesis is the part P of a conditional statement following the word if. And we want to get in the habit of circling the word if, because notice it says following the word if. So the word if is not part of the hypothesis. The conclusion is the part Q of a conditional statement following the word then. So we're going to get in the habit of circling the word then, because the word then is not part of the conclusion, and we will double underline our conclusion. We can show this with a picture. So we put in the center of a circle our hypothesis. And if everything is true about the hypothesis inside the conclusion, then we have a true conditional statement. If the hypothesis is not part of the conclusion, then we have a false statement. Example 1, identify the parts of a conditional statement. So I see the word if and the word then. I'm going to circle those right away. I'm going to single underline the words that follow if. That's my hypothesis. I'm going to double underline the words that follow then. That's my conclusion. Let's write that out. So my hypothesis is t minus 38 equals 3. My conclusion is t equals 41. Great. Let's try another example. Let's now write a conditional, which is an if-then statement. So an integer that is divisible by 5 is also divisible by 0. Well, I can kind of play with that. So let me try putting an if in front. If an integer, that doesn't make sense. So if an integer is divisible by 5, we've got a natural pausing point. If an integer is divisible by 5, then it is also divisible by 0. So it takes a little manipulation of the English language, but I think we've got it. So if an integer is divisible by 5, then it is also divisible by 0. Let's rewrite. If an integer is divisible by 5, then it is also divisible by 0. We want to circle our if and our then. Remember, they're not part of the hypothesis, which we will single underline, or a part of our conclusion, which we will double underline always. Sentences can get pretty tricky. Let's take a look at this tricky example. A number is divisible by 3 if it is divisible by 6. Notice that the word if is in the middle. We've seen it at the front. So this means that the hypothesis is now at the end. So if it is divisible by 6, then a number is divisible by 3. There is a little bit of the English language, so it is referring to a number. So we'll need to switch that when we write our conditional statement. So if a number is divisible by 6, then it is divisible by 3. Let's circle our if and our then, and we will single underline our hypothesis, which was originally at the end, and we will double underline our conclusion. Great. Sometimes it's hard to know the truth of a statement, but there is a mathematical way to always determine whether a statement is true or false. We'll use a Venn diagram. So here's our statement. If a student attends Columbia Heights High School, then he or she lives in Minnesota. So the hypothesis is a student attends Columbia Heights High School. So I'm going to put that in an inner circle. Columbia Heights High School student. And the conclusion is that he or she lives in Minnesota. That goes in the outer circle. So here's a Venn diagram. Here's what it means. It means that the set of things that satisfy the hypotenuse, and remember, or the hypothesis, that's on the inner circle, lies inside the set of things that satisfy the conclusion. So does a student who goes to Columbia Heights High School live in Minnesota? Yep, that's true. If it is false, then the statement is false. There is one more thing we can do with if-then statements. We can flip the order. So a converse statement can be written in the form of if Q, then P. I like to think of converse tennis shoes, and my Chucks, my Converse tennis shoes, they move when my feet move. So what we're going to do is we're going to move the conclusion to the front. And so the Venn diagram then switches. So the hypothesis goes in the inner circle and the conclusion goes to the outer circle. So our hypothesis was in pink. That is now in the outer circle. So let's check that out. What happens? So example number 4, writing the converse of a conditional. We're given a conditional. I spy the words if and then. Remember, that's not part of the hypothesis or the conclusion. Our conditional statement is if two lines intersect to form right angles, then they are perpendicular. We got to be aware of what our English language is saying. So they or it, what is it referring to? In this case, it's referring to two lines. So when we switch the order, we can't bring the word they to the front. We have to write two lines. So what that looks like is then if they are perpendicular, but I can't use the word they, I have to go back and see what they is referencing. If two lines are perpendicular, then now I can say they intersect to form two lines. So not only does the hypothesis and the conclusion switch, but if you have any pronouns, not pronouns, but its and they's, you've got to switch those as well. Then they intersect to form right angles. And don't forget to circle your ifs and thens. Our conclusion is now first. Our hypothesis is now last in a converse statement. Great. Now complete the U try.